Problem number 3 from the 2016 practice test FRQs, you had to find critical points, and this is 3A. Now, this is key with these types of problems. Okay, so when you start with this, you're pretty much taking the derivative of both sides, and on this right side, you're pretty much applying the fundamental theorem of calculus. So the derivative of f of x is just f prime of x. So this left side is just f prime of x. And the derivative of this, after you've applied the fundamental theorem of calculus, it's just g of x. So f prime of x equals g of x. And this is what we're going to use to find our critical points. So to find where f has critical points, you have to ask yourself, where is f prime of x equal to 0? Or in other words, when you're looking for the critical points of f, you have to first set the derivative of f equal to 0. Well, if you're looking where the derivative of f is equal to 0, that's like asking, when is g of x equal to 0? And we can just look at the graph, because this is the graph of g. So you'll see that the graph of g happens to have zeros at -6 and at 2. Now notice that we have a critical, it happens to be 0 here. However, it never jumped from the negative side to the positive side. So the reason why this is a critical point is because it changed from negative to positive. This one changed from positive to negative. And here it never changed from negative to positive. So these are the only two critical points. So that's the first part of that question. The critical points are at x equals -6, x equals 2. The next thing we have to do is we have to classify each critical point as a local minimum, local maximum, or neither. And that's pretty much the same as relative maximum, relative minimum. And remember that looking at the graph of g is the comparison of f prime of x. So f prime of x equals g of x. And the reason I say that is because whenever f is negative, whenever g is negative, like there, and down here, that's where f prime is negative. Okay, so that's when f prime is less than 0, and down here, this is where f prime is less than 0, and then when we go up here, that's where g is positive. In other words, that's where f prime is greater than 0. Okay, f prime is positive. I bring this up because at this critical point, when x equals -6, we change from negative to positive. So that means that we have a relative min there, and f prime changes from positive to negative there, so that's a relative max. So that's what you write for the final answer. Make sure you're specific. X equals -6 is a local minimum because f prime of x equals g of x changes from negative to positive there. X equals 2 is a local maximum because f prime of x equals g of x changes from positive to negative there. Remember, avoid using the word it changes. Don't use that, and also try not to be vague. Try to be as clear. Make sure that the reader knows that you know exactly what you're talking about. For part B, we're going to find f of 0, and once again we're going to use that key f of x equals the integral from negative 8 to x of g of t dt. However, we're going to change our x to 0 because we're looking for f of 0. So in other words, we're looking for f of 0 is equal to the integral from negative 8 to 0 of g of t dt, and we're just going to use our graph to get that. So we're looking at the area underneath the curve or the function from negative 8 to 0. So we have some shapes here. What we're really looking at is this triangle. We have a trapezoid, and then we also have a semicircle. Actually, it's not even a semicircle, it's like a quarter circle with a radius of 4. So one thing to notice is that this triangle is underneath the x-axis, so it's going to be negative. Or one way to see it is that the base of this triangle is going to be positive 2. However, the height is negative 2. So when you find the area, it's pretty much base times height over 2. So this triangle will have an area of negative 2. Then we're going to calculate the area for this trapezoid and then the area for the quarter circle. So for the trapezoid, remember it's base 1 plus base 2 times the height divided by 2. And we can simplify this to pretty much say it's 6 plus 4, which should be an area of 10. So this trapezoid gives us an area of 10. The quarter circle, it's pretty much pi r squared, the area for a circle, divided by 4 because it's a quarter circle. And this is pretty much 4 times 4. So 4 squared is like saying 4 times 4. And we can also simplify this one to pretty much get 4 pi. Okay, so it's negative 2 plus 10 plus 4 pi for the area in part B. So this integral is pretty much negative 2 plus 10 plus 4 pi, which is 8 plus 4 pi. That's your answer. In part C, you have to find the limit as x approaches negative 4, and you always should try direct substitution. First thing you should do is try direct substitution to see if that works. Okay, now in the denominator here you get 16 minus 16. Now, how do we calculate f of negative 4? F of negative 4 is pretty much the area of this triangle and that triangle, because if we use the key here, f of negative 4 is pretty much the integral from negative 8 to negative 4 of g of t dt. So the area from negative 8 to negative 4 is this triangle, which we already calculated in part B, and we got negative 2. And this triangle we can easily calculate. It's just positive 2 times 2 over 2, and we get an area of 2. So negative 2 plus 2 is 0. So we pretty much get 0 over 0. That's fine, because now I can use L'Hopital's rule. Make sure you definitely want to show that you got indeterminate form, you got 0 over 0. This is part of your work. If you don't have it, they won't give you full credit on the AP test. Make sure you state L'Hopital's rule. You can put the S, L'Hopital's rules. They won't take away points for for misspelling it or having a specific way of spelling it. They'll take either L'Hopital's rule or hospital rules, whatever. But make sure you're stating these two before you go ahead and apply L'Hopital rule. So what L'Hopital rule pretty much says is, if we get indeterminate form, we can go ahead and take the derivative of the top function and derivative of the bottom function, which I have. And now remember that little key that f prime of x equals g of x. I'm going to go ahead and change f prime of x to g of x.